Two polynomial functions of a higher degree. I feel new man, baby. All right, good deal. 2-2 is a wonderful and time-consuming lesson, but we will strive to make our way through it. Here in 2-2, what we're going to do is going to deal with polynomial functions of higher degrees, which means we're going to have x to the thirds, x to the fourths, x to the fifths, rarely, but sometimes an x to the sixth. And what we're going to do is we're going to use our transformations to sketch graphs, so shifting, reflecting, stretching, and sometimes shrinking. We're going to use our leading coefficient test to determine end behaviors. We're going to find and use zeros to help us sketch. And we might use our intermediate value theorem to help us find zeros. Good times. Good times. Yeah, good times. All right. Anytime you have graphs of functions that have a degree greater than 2, they are a little more difficult to sketch. You can't just use a mirror image like on quadratics, where if you find half of your graph, it's going to mirror image over like your y-axis, or over an axis of symmetry, I should say. So we are going to have to graph these by hand. Make sure you have graph paper. So there are a few things that you need to remember about polynomial functions. They have a nice, pretty continuous graph. So lovely. And then you don't have any breaks. So here, this is like a piecewise function. You don't have any breaks like this. This is not a continuous function. This is a nice, pretty continuous function, and it has some nice curves. It doesn't have just a straight come to a point, moving around. Okay, so you have to have some nice, smooth, rounded turns. Okay, anytime you have an f of x equals x to the n, these are called your power functions. X to the third, x to the fourth, x to the fifth, anything fun like that. All right, so when n is even, that means you're going to have a graph that is similar to x squared and is going to touch the x-axis at your x-intercept. Makes sense. It doesn't necessarily have to go through your x-axis, but it's going to touch it. When n is odd, and that means you have something like an x to the third, x to the fifth, then you actually cross your x-axis at your x-intercept. Even, touch, odd, cross. Exciting. So you can look on the back cover of your book for any characteristics about cubic function, quartic function, and I highly recommend that because there are some pretty important things here that you would want to look and see, domain range, x-intercepts, and stuff like that. So I'd recommend taking a little gander back that way. So for example 1 here, if we are going to sketch these graphs, then we have to try to keep an idea of what they may look like. Here we have an x to the fourth, so it's going to be something similar to an x squared, and that means we're going to be touching at our x-intercept is going to be touching the x-axis. It's not going to be crossing through it. Now we do notice that this is going to have a shift to the left 5 units. Now the reason we know that's to the left is because this is a 5, and since it's plus, we actually are going the opposite direction, so that means you need to go to the left. So when you make your graph, this graph would be best found by making a table of values. So we're going to say x and f of x, and whatever you graph, you should try to put kind of what we would call a vertex in the center. So we're going to put -5 in the center. And you're going to surround that with a couple points to the left, -7, -6. A couple points to the right, -4, -3. And what you do is you plug these into your calculator. Now, when you plug these into your calculator or into your function, sorry, -7 plus 5 is -2. -2 to the fourth is a 16. So you'd go back 7, up 16. Well, that's not going to be in our graph. Too bad. Plug a -6 in. -6 plus 5 is -1. -1 to the fourth is a +1. So we can go back 1, up 1. Plug in -5, well, that's just going to be 0. We have that point. If you plug in a -4 plus 5 is a 1. 1 to the 4th is a 1, so you go over 1, up 1. And then you plug in -3 plus 5 is a 2 to the 4th is 16. So those 2 points, even though we can't graph them, are important because as you go to the right, you cannot cross where x equals -3 because that point is like way up here somewhere. So do not cross on your graph. Do not cross over x equals 2 on what you are given, or x equals -3. Same thing here for the -7. Well, -7/16 is up here somewhere. So as you go to the left, this line should never cross your x equals -7 either. So there is your pretty little graph of x plus 5 to the 4th. Now if we look at B, this has an x to the 3rd, so that means we are actually going to intersect through our x-axis. But we have a couple things here. We have a shift right by 3 units. We also have a reflection, reflect over, sorry, not a reflection. We have a shrink. We have a vertical shrink by 1/4. Vertical, make sure you state if it's vertical or horizontal. Don't just say shrink. You need to say vertical. So we have a vertical shrink by 1/4. So when we make our table, this is shifted to the right 3. So we know we're going to be going, usually our x to the 3rd goes up, looks nice, little S curve. Well, I normally go through 0, 0. We know we're going to be shifted to the right 3. So we are going to have our center of our graph right here. So when we make our table for this function, you need to have x, k of x, and you're going to plug a 3 in, surround that with a 2 and a 1, 4 and a 5, and I'm not going to insult you. I know you know how to plug these in. So when you plug those values in, you get a -2 when you plug in a 1. When you plug in a 2, you get a -1/4. Plug in a 3, you get 0. Plug in a 4, now here you get a positive 1/4. And plug in a 5, you get a 2. So we go over 1, down 2, over 2, down a 4th, right there. Over 4, up a 4th, and over 5, up 2. This is how your graph is going to look, and it should be going up. You can add more points if you want. You don't have to, as long as you have 5, because we should find out where it intercepts our 0 here. Actually, if it intersects 0, that should be at 27/4, which is almost 7, not quite, so I was close. So here's your graph. So that is how you can use your functions. You need to look back in the back flap of your book to see what they look like. See if you can figure out some characteristics that may help you graph throughout the rest of your homework.